Hello guys and welcome back to the channel. Today we are talking about graphs. So if you have no idea about what graphs are and you don't know how they're used in code, then you have come to the right place. So we are going to consider a few questions before we actually start talking. And it's very important, it's very important to have questions before you actually start studying something. The most important question which we need to ask from ourselves is, why do we actually need a separate data structure for a graph? Right, why do we actually need its representation? And then again, this question is directly linked with something which is even more important. What problems does it solve? Isn't it? We need the data structure because it provides us value. And it provides us value how? Because there is a certain set of problems that it solves. What problems are those? So we are going to be having a look at that as well. Now again, once we establish our basic understanding of what a graph is, then we need to see what how do we actually represent a graph in code, in terms of code, right? And then after that we are going to see what operations can I perform using the graph data structure. So let's see a very simple example of what a graph is, right? This is a simple connection of different cities, right? What I have tried to show is that from a certain city, from for example Karachi, you can go to Islamabad and Lahore, and then from Islamabad you can go to Hyderabad and Karachi. From Lahore you can go to Karachi, Peshawar, and for example Sialkot, right? So at this point you might say that this looks very similar to a tree, isn't it? And if we start talking about trees, then how are we used to uh, representing trees inside of our code, right? What we do is we we say, I don't care about the whole tree data structure. No, what I care about is the blueprint of this particular node. So if I observe this, I mentioned actually, by the way, this particular word blueprint, let me actually write that down as well because it's very important. So what we say is, देखो, I don't care about the whole tree data structure. I care about a single node, because if I am able to successfully implement one single node, then the tree is going to make itself up, right? How do I made how do I make one single node of a binary tree? I'm talking about binary trees right now. Let's keep it simple, okay? I'm talking about a binary tree. We say I need a certain data structure, a certain thing which has a value in itself, for example 10, or it can be anything. The value doesn't necessarily need to be an integer data type. It can be a string as well. For example, over here the value is a string, khi it's a string, so this can be anything. Integer, string, character, could be anything, right? So I need one value, and then I need a procedure so that I can connect this particular node to other nodes, let's say node B and node C, isn't it? I need some sort of a mechanism such that using that particular mechanism I can connect one node, let's say node A, to nodes B and C. So what I say is that I need this sort of a data structure which has three partitions. And by the way, this and this, they're both the same thing. Sorry, they are both the same thing. So value will be stored over here, but then this box, what it's going to do is that it's going to store in itself the address of another node. Okay, another node which is of the same time, which is of the same type as itself, and this is also containing the address of another node. So you see, for example, let's say that node A has an address of bx1, node B has an address of ab2, and node C has an address of bc2a, for example. Then what is going to happen is, this is bx1, this is this particular node. In the value it has 10, and over here what it has is ab2, over here what it has is bc2a. So what I'm trying to do is I'm trying to connect one node using pointers. I'm trying to connect one node to two different nodes. By the way, if you don't know what pointers are very simple. Dekho. Pointers, what they do is, a pointer, if I create a pointer ptr, then it points towards something. Now pointers can be of different type. If I do int ifteric, then what I'm doing is I'm creating a pointer to a integer, which means that if this is my pointer, what it points towards is another memory location in which there is an integer. Okay, for example, if I make a character pointer, then my pointer to this is my pointer. Okay, again, this is memory location A, this is memory location B. My pointer points towards something which is a character. Okay, which is a character A. Similarly, what I'm doing over here is, where do I need my pointer to point towards? That's the question. I want my pointer to point towards a node. That is why I'm taking node ifteric. Okay, similar to int ifteric and character ifteric, I want my pointer to not point towards an integer, not point towards a character, but point towards another node of its type. You getting my point? That is why I'm taking node ifteric. But then this is the logic for a tree, isn't it? Can I represent this particular example as a tree? Yes, I can. But then, for example, let's say I do this and this as well. Now it's no longer a tree, isn't it? Why is that so? Because when I introduced these two lines to my tree, it actually became cyclic, isn't it? If I just remove this, then you are very clearly observing that the tree, right now, the tree is acyclic. So any acyclic undirected graph is actually a tree. If you have a graph which is acyclic, meaning it does not have cycles inside of it, and it does not contain, it's directed, and it's directed, so like this, you can go from Islamabad to Hyderabad, but you cannot go from Hyderabad to Islamabad. If you have a graph which is acyclic and directed, then it's a tree. But then if, for example, you do something like this, if you want that functionality that you can go from Karachi to Islamabad and then Islamabad to Karachi as well, then it's no longer a tree, then it's a graph, and then you need a separate data structure in order to represent this graph. All right, now the question which we need to consider is, having had all this discussion, what we have basically established at this point is, why do we need a separate data structure for a graph in order to represent a graph? Now, we looked at how we represent a tree in terms of in our code, right? We create a class, we create a blueprint. Class is nothing but a blueprint, right? Basic object-oriented principles. And then what we do is we instantiate, we make objects of this particular class, and then we connect them to one another. All right. The thing which we now need to consider is, how can I create a graph data structure? The very simple way of doing that is, see, I'm not going to write any code in front of you, I'm just going to write the logic. You'll automatically be able to write the code by yourself. All right, what I'm observing over here is, I'm just going to write my observation. What I am observing over here is that from Karachi I can go to Islamabad and Lahore, Lahore. Similarly, from Islamabad I can go to Karachi and I can go to Hyderabad. So let me just complete this particular adjacency table. All right, so this is basically how my adjacency matrix, or you can say adjacency table, looks like. This is how we represent a graph. Literally, this is how we represent a graph. Now, what is this actually? This is just a way to represent from a certain node, let's say from Karachi, where you can go, from Lahore, where you can go. You can go to these two places, isn't it? Now, thing is, how can I convert this into code? How can I convert this into code? So what you will observe over here is that this is nothing but a simple map, isn't it? This is nothing but a simple map. So what is a map actually? Map is nothing but a key value data structure, right? And over here, what my key is this particular city, and what my values are, where I can go from this particular city. From Hyderabad I can go to Islamabad, from Islamabad I can go to Karachi and Hyderabad, so on and so forth. So it's just a key value store, isn't it? How we create a map in C++ is very simple. What's the key? It's a string. And what are the values? The values are multiple strings. So I can say an array of strings or vector of a string, isn't it? As simple as that, ADJ. This is how you represent a graph. The very first thing, before doing anything, what you're going to do is you're going to create a graph, isn't it? Inside your code environment, inside your code file, the very first thing which you are going to do in order to solve a problem which is related to graphs is that you're going to create the graph data structure. After having created it, then you can do multiple operations on it, right? So the first thing which we needed to do, how to represent, that is something which we have done at this point, isn't it? Now, and let me actually show you that inside of my code environment as well. So what I'm simply going to do is I'm going to take a map of which the key of which is of type string and the values are of type vector of a string, because I can visit multiple places from a certain city, isn't it? And then as you observed over here, from Karachi I was able to go to Islamabad and Lahore. So what I'll do is I will say in ADJ against he, just place an array of strings. Okay, just place an array of strings in which you have two cities. Which cities are those? Those are ISL and Lahore. So ISL and Lahore. Okay, similarly I am going to do for each and every city. So let me just do that. Alright, so this is how I have basically populated my graph data structure, isn't it? As simple as that. What I'm saying is that from Karachi, I can go to Islamabad and Lahore. So against the key of Karachi, I have placed a vector of a string in which I have two cities. And then you must observe that in the place of Lahore, from Lahore I can go to Karachi, Peshawar and Sialkot, but I haven't written Sialkot over here. So I can do this like this as well. ADJ of Sialkot. Now when I write this, when I write ADJ of Sialkot, then it's basically referring to what? It's basically referring to this particular vector of a string. So if I place a dot over here, then it should show me those operations which apply to a vector of a string. Let's see if it tells me that. See, it's telling me. So I can push back. Now pushback is a concept. Pushback is a function which is associated with arrays, and I'm able to use it with connection to ADJ of SKL, isn't it? So that means when I write ADJ of SKL, I'm talking about what? I am talking about the values which are associated with this particular key, which are associated with this particular key. Okay, so over here I can just write SKL. I hope everything is clear till this point. Now after having represented all these cities, now one thing which I would like to see is I would like to basically sort of print something like this, print a table, right, as a proof of concept that whether or not I have the correct data structure. So for that, what we can do is, dekho, very simple. What I'm going to do is I'm going to iterate over my map row by row, as simple as that, row by row. So let's see how we can do that. I'm going to say for auto, I'm not defining the type. I don't know what the type of this particular row is. This is a mapping that I know. I know the theory, but I don't know what the type is. So I'm just going to write for auto. You can write any name, row inside of your map. You can also say line. This could have been line as well. Anything you like. It's just the variable name. I'm going to say print row dot first. Why is this not working? Oh sorry, the name of my map is ADJ. So I'm going to say print row dot first. Row dot first is basically the key, and then I'm going to place some gap over here. Then I know that my values is not one single thing. My values are basically a vector of a string. So I'm going to say for a string, you can say city in what? In row dot second. Row dot second is what? Row dot second is are the values, isn't it? So I'm going to print cout city followed by some space, and then after you have done so for one particular city, for example, for Karachi, I'm just going to change the line. So if I run this code, let's see what output do I get. I should be able to get this sort of a structure as a result of this particular code. Let's see. So, okay, there is something wrong. No, it's what is wrong? Mm, no, I think it's correct. Let me just do this sort of a thing over here. If I run it again, then it's going to be correct. By the way, I made this small correction from SQL. Oh, sorry, from I'm sort of making a mistake over here. What I needed to do was against LHR, against Lahore, I needed to push back SQL, right? So let me make just this uh, very small correction. And, and then there is one very important thing which we are going to learn out of this process. One thing which you are observing over here is that the keys the keys are sorted in alphabetical order: A B C D E F G H I J K L M N O P Q R S T, right? So S is the last character and H is the first character. And why is that happening? Because a map automatically sorts the keys. When I'm using a map data structure, it automatically sorts the keys. But for example, if I just convert this to an unordered map, then by default, it's not going to sort the keys. So I'm going to have the result in the same format: KHI, ISL, LHR, so on and so forth. Okay, let's have a look at that. So as you can see over here, the only thing is the the key which you make at the last, it's going to appear at the top. So it's basically going in bottom to top fashion: SQL, PWR, then Hyderabad, so on and so forth. So SQL, PWR, then Hyderabad, so on and so forth. And then keys at the very bottom because it was the first thing. So we have established in this particular problem how can we create a very simple graph. But then let's make this particular problem a bit more interesting. All right, let's say that we are associating different kilometers as well. So how many kilometers do you need in order to go from Karachi to Islamabad? Let's say 10. Over here, let's say 20. Over here, let's say 50 and 60, and let's say 5, so on and so forth. Right now, the graph which I made in front of you inside my code environment, it was unweighted graph. It had no weights associated with it, or it had no cost associated with it between the nodes, isn't it? The edges were unweighted, were non-weighted. They did not have any weight associated with them. But then now, since I need to associate costs with each and every edge, how am I going to do this? Isn't it? And see, the solution to this problem is very simple. If your data structures are strong, then it's very simple. Right now, what you are doing is the array which you have made over here against each and every key, the array which you have made is just an array of strings, isn't it? Vector of strings. But let's say I change this particular data type, and what I'm trying to do is, you see, now my updated graph, how my updated graph should look like. My updated graph should look something like this. So in order to reach Islamabad from Khi, I need to go 10 kilometers. And then in order to reach Lahore from Khi, I need to go 20 kilometers. So instead of simple strings, what I actually need is a pair, isn't it? I need a pair of string comma int. Make sense? I need a pair of string comments. So that way I can associate weights with the edges as well. In order to reach Islamabad, I would need 10. I would need 10 kilometers. In order to reach Lahore from Karachi, I would need 20 kilometers. So the only change which I'll have to make, is what? Instead of a string over here, I would need to do pair of int comma int. right? As simple as that. Sorry, not int comment, if string comment. And then what I'm going to do is, rather than this being ISL, I'm going to do something like this, make pair. And firstly, I'm going to write ISL. The second parameter is going to be 10. All right, so let me do this for each and every entry that I have. All right, so this is the complete picture. You can either use the make pair function, or you can just create a pair like this as well. This is another way of creating a pair. This is one way, this is another way. The objective is the same, these are just two different ways of doing the same thing. So again, since I have made change to this particular to the data structure, and then I have changed this particular the way of populating it as well, I will have to change the way of printing it as well. So right now, instead of having the values as if strings, what I have is a pair, isn't it? So I'm just going to write auto over here in order to simplify things. Or maybe chalo, let's make it more accurate. This is a pair of string comma int. Every city now is a pair of a string comma int, where the first thing which I have is the city, and the next thing which I have is the kilometers, isn't it? I'm just going to say let's say, or let's keep it simple, let's keep it city. This is the variable name, so let's keep it city simply. And then what I'm going to print is city dot first. Now city dot first is basically the name of the city, and city dot second will be the kilometers that I need. So after having a little bit of space, I'm going to print city dot second, followed by some space and maybe a comma over here. All right, now if I print this particular code, let's see what result do I get. I have an error. Yeah, I was just sort of missing this very small greater than sign over here. All right, so that was the only mistake. And as you can see very clearly over here, against Karachi, what the graph data structure is telling me, that in order to reach Islamabad, you need to go 10 kilometers. In order to go Lahore, you need to go 20 kilometers. So this is as simple as it gets. In order to represent a basic graph, a weighted one and a non-weighted one, this is the only thing which you need to know. Now in the next video, what we are going to cover is this, the concept of a minimum spanning tree, and what exactly is Dijkstra's algorithm. Let me just give you a very brief sneak peek of what we are going to try to do. Let's say this graph was very complicated. This was something like this. I had 100 over here, and then I had 20 over here, and then let's say 5 over here, and then maybe 10 over here, and then 25 over here as well. And I asked you that what is the shortest way, what is the shortest route that I can take from Karachi in order to reach Sialkot? What's the shortest route that I can take? So I have multiple routes, right? 20 and 5, 25. I have 25 and 10, 35. Then I have 10, 50, 100 and 10, so on and so forth. I need to be able to calculate all the routes and then see which one is the shortest, which one would take me the least number of kilometers. How do we do that? That is something which we are going to cover in the next video, and I hope you see that as well. Take care.